So this is activity 8.2, the parametric constraints, and I'm going to walk you through how to do number 1 on this. So number 1 is pretty straightforward in the fact that the activity gives you a chart to show you what each thing is. So like D1 is the overall plate width, and then it says that's 5/3 the ratio of the overall plate width to the overall plate depth. So we already had a value for the overall plate depth. It gives you the equation for the parametric constraint. So D times 0, or D0 times 5/3. And then it goes to the plate thickness, and it tells you that's 20 times smaller than the overall width. So I'd have to do the overall width, which is D1, and I'd have to do that divided by 20 because it's smaller. This one is just 0 degrees. We're not going to use anything to make that happen or change that. And then we have our slot width. It says 1/2 the overall plate depth. So to go back, overall plate depth was D0. So we're going to do D0 and divide it by 2. The next one, we don't have the answer to it, so we would have to make an equation. And so a lot of times I'll walk through a couple of these with my students and try to make sure they understand exactly what goes here. So 4/5 of the overall plate width. And I'll ask them questions like, where is the overall plate width? And we'll go up here. D1 is your overall plate width, so it's 4/5 of that. So just D1 times 4/5. And that would be our equation. The next one says 1/3 of the overall plate depth. Again, overall plate depth is D0, so just do 1/3, or D0 times 1/3. And I tell the kids, there's a couple ways you can do those things, or you can do D0 divided by 3. All those equations mean the same thing. But the whole point is once they get this equation created, they can go in and they can start working on Inventor. And the whole point is your project should look like this. And the big things you have to kind of realize is these shapes that are here are what we need to make sure we're following. So like if D0 is this, I want to make sure that's the first thing I do. And then D1 would be the next dimension that I do. So let's start with that. I want to go in here and just make a part on Inventor. And I would start a 2D sketch. And I would just make a rectangle first, because we know the basic shape of what we need is a rectangle. So I'm going to go back to this again, and it tells me that D0 is really here. All right, so let's do that first. And D0 is supposed to be 3 inches, so that's going to be the first thing I dimension. So dimension, click on this line, and I'm going to make it 3. And notice in here where it says edit dimension, and it says it's D0. So it gives you that overall, like what number or what dimension you're referring to. So that equals 3. All right. Now my other one is going to be a parametric constraint. So I'm going to write the equation that we have here. So D0 times 5/3. So that's for my D1. So I'm going to click here. And I'm going to tell it D0. And I'm going to do times 5/3. Okay? And that gives me my overall shape. Try to get that out of the way. Alright, then we're going to finish sketch. The next thing on our list says that the plate thickness is 20 times smaller than the overall width. So it's D1 divided by 20. So I'm going to go in and I'm going to extrude it. D1 divided by 20. and then it gives me a check mark. All right. Now, if you are going in to look at your overall dimensions and see like what these are, the other thing you have to realize is when you do a dimension for an extrude, you have two dimensions that happen there. You have one for how far you're extruding, but also you have a taper, and the taper was 0 degrees. So we just left that as is. We didn't change anything. So that's what actually takes on your D3. So that one's taken care of. The other nice part is you can go in here under Manage, and I can look up parameters. And I can see what I've typed in so far. So I've done D0 is 3, D1 is D0 times 5/3, D2 is D1 over 20, and my D3, like I said, is automatically done in 0 degrees. So far everything we've done has been recorded in here. And the interesting part about it is I can go in here and I can change this dimension. I put in 4 inches and I hit done. And notice it changed everything. I can go back in and see how all of these have now changed. So I don't want to change them. I need to go back to the original. But that just gives you kind of a hint of how it actually works. So now I change it to 3. It all goes back to the right sizes that I need. All right. So then we're going to go back to our page. And then it says D4 is your slot width. So let's look at D4. D4 is from here to here. So we need to draw our slot first, is what I tell my students to do. And then we'll put dimensions in later. So in order to make the slot, I usually tell the kids I make just a rectangle with 2 circles on the end. And notice I make sure that I add a green dot so it's centered. And make sure it goes to green dot so it's touching the edge. And so that locks that in. Then I'm going to go in and I'm going to trim out the unneeded line. So now it actually looks like a slot. And then I'm going to double check just to make sure that it is completely tangent. So it's smooth with my object. So now I know that it's a solid piece. So if I try to do something with it, it should all work together. So according to my paper, my slot width is supposed to be D0 divided by 2. So slot width from point to point is D0 divided by 2. Alright, and it's going to move stuff. It's okay. The next thing I'm going to have is the slot width location is 4/5 the plate width. So that's D1 times 4/5. And if I need to remember where that goes, it's here, D5. So dimension from here to here. D1 times 4/5. So the next thing you need is your slot depth location. So it's 1/3 your slot depth. So 1/3 D0. So dimension 1/3 times D0. Okay. And then D7 is our next one, which is actually our radius, and that's D2. So then our radius is going to be D2. And so our slot looks back to normal. So then we can finish our sketch, and we get our extruded height, which is dA, which is the same as the plate thickness. So our plate thickness was D2. Finish sketch, extrude, click on your cut button, change it to D2, and then click on your face. So there's your slot. Then we can put your hole on your face. So I'm going to turn it in front so I can actually see. So on your hole, you have a couple things. Your hole width location. So that's this way. and that is 1/4 the overall plate width. So 1/4 D1. So I can click on over here for my reference point. So reference from here, 1/4 times D1. Okay. Oops. Go back and edit my hole. That wasn't finished. The second thing on D11 says the hole depth location is 2/3 the overall plate depth. So 2/3 D0. So we're getting from this corner. Actually, should be the other corner. Let's pick that one. Reference from this side. 2/3 times D0. And then my radius is D12, which is 2 times D7. So 2 times D7. All right. So it looks a little off right now. So if I look at my manage and I look at my D10, my D10 was supposed to be 1/4 the overall plate width. Well, it looks like it just did the 1/4. So I got to fix that. So overall plate width was D1, so it should have been 1/4 times D1. So anytime it doesn't always go back, I can go back in here and I can adjust it on our parameters. Hit done. So now it's better in the right location. All right. D13, which we didn't really pick, but the locate or how deep it goes, we can change it to the distance, and we can tell that the distance should be same as the slot height. So slot height is your extruded, so it's equal to D8. It's equal to D8. So adjust that. And then the small hole taper is going to be equal to D9, which is just equal to 0. So all that stays equal. So then there's your piece. So if I adjust any of this, enter my parameters, it would change everything. So if I hit change this to 2, everything is changed. I go back to the original.